Welcome to the channel where all you gotta do is design an intake manifold. Today I'm just kind of sciencing out what problems I'm going to run into so I can come up with solutions for them and get them in CAD. So I want to get, we got throttle bodies on here. That's approximately what the intake manifold is going to look like. And then there's an intercooler that goes between here and here. So that'll diffuse out. So it goes into the plenum the whole width. So I don't have like typical log intake plenum, you put the air in the front here, and then this one gets the most, and this one gets a little bit less, and this one gets a little bit less, right? And if you put it in the center, this one gets the most, and these two get less, and these get really less. So I'm gonna go through the intercooler, which makes a really good flow straightener. So that's gonna diffuse the air to both ends of it, just because it will force it to use the entire core because there's some restriction through it. So it's gonna go through the easy way, and that'll instead of putting like a dual plenum. Not sure if you're familiar with a dual plenum, but I can put a picture up here on the screen what a dual plenum intake manifold looks like. Okay, so I got a haphazardly drawn schematic of a typical layout. This would be a 5-cylinder inline, V10, whatever, inline 6, could be turbo. Typically what you do is you feed it into an intercooler. It comes on a, through a hump hose or whatever, a couple inch pipe, 2.5 inch pipe, whatever. And then it diffuses out to a bigger area, and then it goes through the heat exchanger, a little X, that's the heat exchanger there. And then it collects all that air and goes back to a 2 inch, 2.5 inch, whatever, round hose. And then another elbow or whatever intake air tube to go into your throttle body. And then now you're still at 3 inches or whatever, 2.5 inches. And then you got to get into all these cylinders that are in line. So some people just do this, right? They just have it on an angle and that's it, right? And this is all, this partition doesn't exist in here. It's just all open, which is fine, but this air will get more, this cylinder will get more air than this one. So what people do is if you draw a cross section of this, here's your bell mouse like that, and there's your valves are down that way. And then on this end you have your throttle body inlet, but instead they put like a partition here. Kind of drew this poopy, but so your throttle body is there on the end, and then all the air fills up this plenum here and kind of makes a, all this area is the same pressure as the pressure in that hose, and then it has to all funnel through this little slot right here, which is 3/4 of an inch, an inch wide, something like that, depending on, right? And then that makes it so the pressure on this side of the plenum and this side of the plenum is the same. So complicates the intake manifold, but it does improve performance. You get cylinder charge is much similar. However, this restrictor here is just a restrictor. So in order to get past that restrictor, you have to run higher pressure here than here. And the higher pressure means you have to do more work to pressurize it. It's just a loss, right? So, but there's already a pressure loss between here and here across the intercooler. So what I'm doing, and due to packaging reasons, I put the intercooler here, and then I put my throttle body, actually it isn't a throttle body because I got individual throttle bodies down here, but the inlet is there. So this gets diffused through the heat exchanger intercooler core here and essentially has the same pressure all the way along there. So the little slot here I'm replacing with an intercooler that's doing me good, right? It's lowering the air charge temperature. So I get something for the pressure drop, whereas a dual plenum intake manifold, you get the pressure drop, you get the charge the same, but you pay for it in and having to have the turbo work harder. Turbo works harder, makes charge temperature hotter, makes exhaust gas or exhaust pressure higher, right? So anyway, that's my solution. This totally works. Like, millions of these are in the world right now. It works fine. But if you're going to do something, you might as well do it the goodest possible way. So that's what I'm trying to do here. Okay, so this is what I came up with. It kind of looks like my cardboard cutout. So this is the intake manifold. That's the inlet. That happens to be the driver's side. That's the passenger side. And this is the trumpets that go to the individual throttle bodies on the S85. And that's a drain plug there. His PCV kind of fills that up. This is a plethora of boost ports. There's no vacuum there. That's just boost. So to run that to a manifold air pressure sensor or whatever, that's what those are for. I don't know how many I'm going to need, so I just put a plethora of them in there. This is the fuel rail. This is exclusively for E85 that feeds the top of the trumpet. And there's 10 injectors as well. And those are the water ports for the intercooler, inlet and outlet. On the back there's inlet, front the outlet. This is just the end tank for the intercooler. Let me do a cross section through here, but basically this is all where these little radiuses are. That's a different shade of purple. Those are all welds. So the rest of the stuff will all just be bent up sheet metal, 1/8 inch thick aluminum, and spark welded together. Okay, so on the inside there's a little bit more going on, but these are end tanks. So the water goes in one end and out the other, both sides. And then the part that's clear, that's the fin area. And this is the diffusion area. So it comes out of the turbo through this prefabbed thing. It'll be welded, purple and blue will be welded together, and then it goes through the end and comes out to fill up this main plenum. These valves are, again, prefabbed on a lathe, just a turned piece of aluminum. And I have these little pods here that basically the only purpose those have is to hold the second set of injectors for 85, and those squirt right down the trumpets. Like, there's a throttle body down here. So the way this will work is when you're just cruising along on the highway or idling in traffic, the primary source of fuel will be the gasoline, but these things will never be off, right? You never want to, well, not never, but you typically want to run, anytime you're running the car, you want to run fuel through all the injectors. So these will be on some percentage of the time, maybe 90%, or 90% gasoline, 10% E85 when you're just cruising down the road. And then when you're wide open throttle, you want these to be 100% E85 because you need the octane and the charge cooling and stuff like that. So this is the fuel rail. So fuel comes in at the back. Unhide this section. Comes in here. Goes to the front. And then this is where it makes a loop-de-loop and comes around and goes back that way. So this will be drilled from both sides. This hole here will be drilled from both sides because it's already a long drill. And then there'll just be a plug here and a plug here. Instead of having a hose make a loop-de-loop, I'll just put a plug there, and then a larger plug here, which will be an SAE O-ring Boss plug. The way I'm retaining this, it's kind of a twofold scenario, is I have these pieces of aluminum, because this is going to have, 15-ish pounds of boost, 12 to 15 pounds of boost. So this is a lot of area, so there's a lot of force trying to make this thing explode. So that's what these are essentially for. These are just tie bars to keep this and this from exiting stage. It's also nice to not have this flat, right? This gives a little more stiffness to it. This here, if this was just flat across there, it would totally want to bend. And then that's what these slots are here for. Like these, this will be welded to the top side of the intercooler and the bottom side of the intercooler. So that'll keep this from separating from this, right? So yeah, that's it. That's my solution to not have to have a dual plenum intake manifold. This isn't a light setup. I think this part here is, let's see what it weighs in real time, 12 pounds. So just this purple part weighs 12 pounds, plus these guys are a few pounds each, and then all these little giblets and fuel rails and fuel injectors and, you know, water inside these intercooler cores. So this thing's going to be, you know, not light. But I think if I weighed the plastic ones that came on the M5 or the M6, they're pretty heavy. They're pretty hefty plastic because there's no vacuum in it. Yeah. Anyway, that's how I'm going to do that. A couple other features. I'm not going to have a way to get the intercooler out. So the intercooler will be captured inside, and this will just be welded around the outside of here, the outside of here. Same thing on the back. So I will weld the end tanks onto the intercoolers first, pressure test them, and then I'll slide them in to this housing, and then they'll kind of be stuck. And then these bell mounts here, there's a little bit extra material there, so I can weld around, you know, this is like a little bit extra filler metal. It'll weld easier with this kind of sharp edge there. So, and then this is a drain because intake manifolds sometimes fill up with positive crankcase ventilation fumes. So that's a drain. I don't know if I mentioned it earlier, but these tie bars are actually the hold downs. These will be threaded at the top, and three M6 screws will be going there, there, and there. And then, because this is just held on with basically a rubber hose, these stick out of the bottom, and that'll be attached to the block itself. So once these things are all clamped in place, those will keep the whole thing from trying to, you know, jump through the hood. Okay, so this is the intercooler I've selected. So there's two of these. They weigh about 3.5 pounds each. And this is designed to be a liquid to air. So liquid goes through this end. So I'll have to make a little sheet metal intake, or maybe I'll make a billet intake, I don't know. So this end, so water goes through there, and then the charge air goes through this side. And this is like 3.7 tall by 3.5 wide, I think, and then 15.5 from end to end. So it's pretty decent size. So the thing that you want to look at with the intercooler is you don't want to use an air-to-air intercooler, because in an air-to-air system you have to have really low restriction in these air side fins, or else you don't, right, there's no, like if you put this on the front of your car, no air will go through this, it'll just go around it. There won't be enough stagnation pressure to push it through. But when you have this inside your intake manifold, you have plenty of pressure, right? You have 15 pounds of boost trying to push it through, and you actually need a little bit of restriction. Otherwise, if it's too free-flowing, like, it won't diffuse out into this area. It'll just, like, if your inlet from your turbo is right here, it'll just all go through right here. It won't even use these other fins, and that doesn't help you. You're just adding bunch of extra weight for no reason. So you have to have the fin density appropriate for what you're doing with it. So this one actually looks a little bit too coarse for my liking, but we'll see if we can get some information from Bell Intercoolers, who is the company I bought this from. It was about, each core was about $200, $212 each or something like that. Which is not bad. Having ordered custom intercooler bricks for when I owned Allen Superchargers, those were like, they were quite a bit smaller than this, and that was many years ago. But those are like we paid $140, give or take, for those, and that was way smaller. That was like 5 1/4 inches wide and 2 1/4 thick and like 7 inches long. So we called them bricks because they were literally the size of a brick. The other options I had were, doing something like an off-the-shelf intercooler you can buy from, I'm not sure how great they are, but there's some companies out there selling intercoolers that already have the manifolds welded to them, right? And you can get them with an end feed or a front feed or whatever. I'll put a picture in there of the website, but Frozen Boost or something like that sells on. But if I would have bought one of them, then I would just have to saw the manifolds off anyway, and then when you saw it off, you get garbage in there, so you got to do a really good job of cleaning it and then weld the new thing on. It's like, yeah. So I highly recommend not doing stuff like that. And there's this company, Bell Intercoolers, that have all different sizes. They probably have 100 different core sizes on their website, and you can just kind of pick what you want. And this one, I think I ordered it, and 4 days later it showed up in my door. Thanks for watching. If you like this content and want more, subscribe, like, and share.